Hey guys! Welcome back to my channel. In this video you will learn about chemical reactions occurs in breathalysers. But before that we make sure to subscribe to our channel and turn the notification on, so you don't miss any videos in the future. Drink driving have always been global problem worldwide. The statistics for total fatalities were quite high due to drink driving back in 20th century. Since the introduction of breathalyzers around 1982, the incidents related to this problem started to decrease dramatically. How does breathalysers works? Before that you should be familiar with the Henry's law. In chemistry, Henry's law is a gas law that states that the amount of dissolved gas in a liquid is proportional to its partial pressure above the liquid. As such, to determine the blood alcohol concentration in human body, this law is referred to the amount of alcohol that is present in the blood is proportional to the amount of alcohol in a motorist's breath. As such, breathalysers measures the amount of alcohol concentration on the breath which is equal to the blood alcohol concentration. The very first breathalysers was invented in United States on the 1930s by scientists Raleigh Harger and Glenn Forrester. They used a balloon within the device which was blown up by the motorist. Then it will pumped through a solution of acidified potassium permanganate. This acid has dark purple color which after the motorist blew it becomes colorless and the permanganate ion is reduced to the manganese ion, which the blue shows the half equation for this reaction. Any alcohol in breath will be oxidized to ethanoic acid. This reaction uses some of the permanganate and the solution loses color and becomes paler. As the color changes from dark purple to paler purple and eventually to colorless, the greater the color change, the more alcohol will be present in the breath sample, which below shows the overall redox equation for this process. Alcometer. This device was invented after the permanganate method which was explained before. For this device the solution of iodine was reduced to iodide. In the presence of a starch indicator the iodine solution is colorless or white, but it changes its color to blue in the presence of iodide. This equation shows that the ethanol is oxidized according to the half equation and the overall reaction for the process is shown blue. This method to determine blood alcohol concentration was not as reliable and stable as it was expected, therefore it was removed quickly. Photocells. Photocells detect the color change more accurately. In this instrument instead of permanganate the acidified dichromate was used. The dichromate ion has yellow-orange color which undergoes reduction in an acidified solution to form the chromium ion which has green color. The ethanol is then oxidized to form ethanol. The overall chemical reaction for the process is written as follows. The dichromate has reacted with the ethanol in the breath sample. The resultant solution is compared to a separate sample of unreacted dichromate. The colors are compared by using a photocell. The photocell creates an electric current that is proportional to the amount of color change. However, in permanganate and dichromate tests the organic substances similar to ethanol often give false readings. All alcohols and aldehydes can be oxidized by the same chemical methods. Electrochemical cells. In this method it measures the flow of electrons. To avoid using color-based indicator, a fuel cell was developed as an alternative. The half equations involve the transfer of electrons so an electric current is produced. In this way the concentration of ethanol in the breath and blood can be determined by the measuring the current. The reactions happens in electrochemical cells are as following. The first equation shows that oxygen is reduced in acidic conditions to form water. The second equation shows that ethanol is oxidized to ethanoic acid. The final overall reaction is written as following. Ethanol reacting with oxygen gas to form ethanoic and water solution. Was the lesson for today. I hope you have learned something new today with us. Thank you for watching my video.